Hello everyone, welcome to a new chapter that is waves. So this one new chapter in physics. We're talking about the waves. Starting with first subtopic that is the introduction to waves. So here we basically see the concept of the waves. The concept of waves. A wave is simply a disturbance that travels through a medium from one location to another. So that kind of a disturbance that travels through a medium, an example, liquid, uh, maybe example water, from one location to another location is what we call the wave. Now, uh, let's see that waves can be classified into various classifications. So the waves are classified into as follows. The first classification of the waves are the transversal waves. The transversal waves, these waves are those which have their direction of motion perpendicular to the vibration of the particles. Take an example, the water waves, as you can see here. This is an example of the transversal waves. So the transversal waves, these are just the waves which they have their direction of the motion perpendicular to the vibration of the particles in them. The other classification of the waves is the longitudinal waves. The longitudinal waves, they have their direction of the motion are parallel to the direction of the vibration of the particles. Take an example of the sound waves. So the transversal waves, they differ to longitudinal waves in terms of their direction uh, relating to the vibration of the particles. In the transversal waves, the waves they have their direction uh, of motion perpendicular to the vibration of the particles. While in longitudinal waves, the waves they have their direction of motion parallel to the direction of the vibration of the particles. Of that's clear. Now they consider a slink wave as an example of a wave. As you can see, this an example of a wave illustrated by this uh, tool or equipment that is a slink. Uh, Now from there, when the swing is stretched from end to end and is held at rest, it assumes a natural position known as the equilibrium or the rest position. So as you can see here, when you're trying to stretch this link from one end to another end uh, and held at rest, it assumes a natural position. That natural position is commonly known as the equilibrium or the rest position. Now, the cause of this swing naturally assume this position spaced equally far apart. Now, to introduce a wave into this kind of a tool or equipment, the swing, uh, the first particle is displaced or moved from its equilibrium or rest position. Now, the particle might be moved upwards or downwards, forwards or backwards, but once moved, it is returned to its original equilibrium or rest position, as you can see, as we've seen from the diagram. So, if we've seen from the diagram, if you get this kind of a tool, this link, you can see its movement and how it maintains its equilibrium or returns to a rest position. Now, the act of moving the first coil of the sling in a given direction and then returning it to its equilibrium position creates a disturbance in this kind of a device or tool in the sling. Now, we can then observe this disturbance moving through the sling from one end to another. Now, observing this, if the first coil of the sling is given a single back and the fourth vibration, then we call the observed motion of the disturbance through the sling a slinky pulse. Now, you cannot wait there, you cannot wait there, that is a pulse. A pulse is simply a single disturbance moving through a medium from one location to another location. Now, however, if the physical of the string is continuously and periodically vibrated in a back and forth manner, we would observe a repeating disturbance moving within the string that endures over some prolonged period of time. Now, the repeating and the periodic disturbance that moves through a medium from one location to another is referred to as a wave. So from there, we get the meaning and the correct and the define the meaning of the wave, that is the repeating and the periodic disturbances that moves through a medium from one location to another. Now, a medium, we've seen a term medium, when we're discussing, a medium is simply a substance or a material that carries the wave. Now, we've perhaps said of the phrase news medium. A news medium refers to various institutions, newspapers, office, television stations, radio stations, etc., within our society that carry the news from one location to another. So from there, you get that word, the medium. It's just a substance or material that carries something in terms of here, the news media. Now, the news moves through the media. Now, the wave medium is not the wave, and it doesn't make the wave. It merely carries or transports the wave from its source to other locations. So that you have to note. In the case of slinky wave, the medium through that wave travels is the slinky coils. So the slinky coils are the medium which carry the wave from one location to another. Now, in the case of water wave in the ocean, the medium through which the wave travels is the ocean water. In the case of sound wave moving from the church choir to the pews, the medium through which the sound travels is the air in the ocean. And here is a simple diagram. Image that shows the ocean water as the medium for the water waves. So that's all I have for this session. I hope that's all clear in this new chapter. Waves, we've seen the concept of the waves, we've seen the meaning of the waves, and we've discussed it in detail to get the meaning of this word wave. Hope that's okay, and thank you.